Aloha! Today is Tuesday and it was Hawaiian Day at virtual school. So my flower, I'm kind of dressed like I'm Hawaiian a little bit. So anyway, we are starting trigonometry today. It is chapter 13 in Algebra Nation, page 276. You may actually want to watch it today or go to Khan Academy or YouTube or meet me on Meet tomorrow. So anyway, we're going to be studying the unit circle. The unit circle is made out of triangles, the right triangles. So I'm going to refreshen you on sine, cosine, and tangent. Anyway, I'm going to start off with a right triangle and labeling a right triangle. That's the first thing you're going to be asked to do. This marking right here is, of course, for a 90-degree triangle. And then this symbol you may not be familiar with is a theta symbol. A theta is like an X in algebra. It's an unknown angle, so we give it a theta symbol. Now, I already have marked your hypotenuse. Your hypotenuse is your longest side of a right triangle, and it's always across from the 90-degree angle. Always across from the 90-degree angle. Now, marking your opposite side, well, your opposite side is opposite your hypotenuse. So this would be your opposite side, and then your adjacent side is your side that touches your hypotenuse. Like Miss Cynical's room was adjacent to my room back in our good old portable days. So her room was adjacent to mine. It's side by side. So these are side by side, so this is your adjacent side. So you need to know this. Larry, stop barking. Sorry, there goes my chihuahua. Every day you get to listen to my dogs. So anyway, these are the sides of your right triangle, and it's for your right triangles only. They have to have 90 degrees. So, oh my goodness, right triangles. So we can come up with the trig ratios. Okay, I have to run real quick and give him something to eat, so he'll shut up. Hold on, be right back. Larry. Here. Okay, I'm back. Hello, sorry about that. Okay, so this gives us sine, cosine, and tangent. That's how we find our trig ratios. I don't know who your geometry teacher was, but we have to find sine, cosine, and tangent by saying, I use SOHCAHTOA. SOHCAHTOA is going to help me to know what sine, cosine, and tangent are. So I want you to write this down somewhere on your paper. SOHCAHTOA. SOHCAHTOA stands for sine is your opposite leg over your hypotenuse. So sine is opposite over hypotenuse. So if I say, what's the sine of this theta? It would be the opposite leg over the hypotenuse. What is cosine of this theta? Cosine is ca. That's adjacent over hypotenuse. So that would be this leg over hypotenuse. So it's adjacent over hypotenuse. It's just putting your legs in an order. And then tangent would be TOA, which is opposite over adjacent. Opposite over adjacent. And you may be going, yeah, so? Well, if I put numbers here on this triangle, so let's say I gave that a 3, and I gave that a 4, and I gave that a 5, and I said, what is the sine of this theta? What is the sine of this theta? Well, now that I actually have the measurements of this triangle, if I say, what's sine of theta? You would go, okay, so sine is opposite over hypotenuse. So you would say it is 3 over 5, which is 3/5. That would be the sine of that triangle, or sine of that angle, 3/5. That's where you use the trig ratios. So SOHCAHTOA. And then how do you remember SOHCAHTOA? Well, I use it like this. Some old hippie caught another hippie tripping on apples. Tripping on apples. That's the G version. G-rated version. Some old hippie caught another hippie tripping on apples. Sokotoa. Okay, or that's the name of an Indian princess, if you want to get really pretty about this. Okay, so those are your trig ratios. Okay, trig ratios. I'm sure maybe it's coming back to you from geometry. Let me scoop this up for a minute. Now here's something, these are special right triangles. This is something you're going to have to know to help you out for the unit circle. We got the 45, 45, 90 and the 30, 60, 90. This is going to be real important for your homework for you to remember along with the Sokotoa. So here, this is a 45, 45, 90. Of course, this is 90 degrees. And let me ask you this question first, that I wrote this down, it's not in your notes. What is the sum of all the angles of a triangle? Do you guys remember? Well, it's got to be greater than 90 if that one angle is 90. The answer to that is 180 degrees. Hopefully everybody remembered that. So if this is 90, and I told you this is a 45, this has to be 45 also. Okay, now this is something you need to mark down. This is really important. So on a 45-45 triangle, the two legs are congruent. That means they're equal to each other. So this would be X and this would be X. That means they're both the same. So if this was 5 inches, this would also be 5 inches. Now to find the hypotenuse here, you would take whatever the leg is and you would multiply it by the square root of 2. So if my leg is 5, the hypotenuse would be 5 times the square root of 2. And if I knew the hypotenuse to find the leg, well, what's the opposite of multiplication? Division. I would just have to divide going backwards. So it's multiplication. You multiply to get the hypotenuse. To go backwards to get a smaller leg, it only makes sense, you would divide to find the smaller leg. Okay, so that's the rules for 45, 45, 90. Okay, let's look at the 30, 60, 90. Well, again, the sum of all these triangles has to equal 180. So if this is 60, this is 90, this has to be 30. Okay, so I know this is the hypotenuse. So this is your hypotenuse. This across from the 30 is your smallest leg. Here's the rule. Across from the smallest angle is the smallest leg. Across from the 90 is your hypotenuse. That's the longest leg, the longest side. And then across from the 60 is your middle. So here's the marking on the 30, 60, 90. This is always, let me get a different color so I can make sure you see it. This is always marked with an X. Then the hypotenuse is always double this. This is always twice the smallest leg. And then across from the 60, it's always, this is one no one likes, it's always X times the square root of 3. Okay, so let me make one up real quick. So I'm just going to add one real quick. Same measurements. This is 90. This would be 60. This would be 30. So if I made something up and I said this was, let me make it easy, 20. So that means the hypotenuse would be double this, 2 times my smallest, which would be 40. And then across from the 60, it would be this X times the square root of 3, or 20 times the square root of 3. And you don't have to multiply those together, you just leave it just like that. Done, just like that. Okay, moving along. I know this is kind of quick. Now I'm going to show you how much time do I have. Oops. Gotta go quick. So I wrote down, this is on your second, and I didn't do all the problems because I'm running out of time. So this is, I wrote down Sokotoa so you can remember. Some old hippie caught another hippie tripping on apples. Sokotoa right there. So on kind of your homework, if I gave you this and I said, okay, find the sine of C. Well, let's remember sine, so I'm looking for opposite over hypotenuse. So I'm looking at this and going, okay, well there's my hypotenuse, so there's my h. I would label the sides first. And now I need opposite my hypotenuse. Well, my bad. Let me back up a minute. I'm looking for the sine of C. So they're told you what angle we're looking for. I want, this is my theta, so circle it. So there's my hypotenuse. Now, what side is opposite that angle? What side is opposite that angle? Well, not 40, it's adjacent. 30 is opposite, so that's my opposite side. So opposite over hypotenuse would be 30 over 50. By the way, this is number 2 on your other set of note worksheet. This is number 2. Okay, I'll give you a sec. So then, do I leave it like that? No. What do you do to all fractions? You simplify. Well, 0 for 0 cancels out, so the sine of this would be 3/5. There's your answer. Okay, go to number 4. Number 4, I have cosine of A, and then I look at cosine of A, cosine of A. Oh, by the way, number 4, I changed it. I changed it because I wanted something different. So I changed this, I can't remember what it was, but I changed it to A. So make sure you mark that on number 4 on your notes, it's an A. So I'm going to circle this, I'm looking for this angle. Okay, now let's mark it. Across from the 90 is your hypotenuse. And then, so I'm looking for cosine. Cosine is cosine, adjacent over hypotenuse. So which side would be adjacent? Well, my adjacent side to angle A is this. The 8 is the opposite side. The 15 is the adjacent. So this is my adjacent. So adjacent over hypotenuse. This is adjacent. This is hypotenuse. So this is going to be 15 over 17. I can't simplify that, so that's my answer right there. And then the next one on this is tangent. The tangent of x. So let's go find our angle. So I'm looking for this angle right here. So tangent is opposite over TOA. SOHCAHTOA. So I'm looking for opposite over adjacent. So opposite of my x would be 36. And then adjacent would be 27. Now because of my door handle, I'm going to put my answer underneath here. So I can divide, now do not make it a mixed fraction. I mean a mixed number. Please leave it improper. So I can divide those both by 9. 36 divided by 9 is 4. 27 divided by 9 is 3. So I get the tangent of x equals 4/3. Okay, probably going to have to send 2 videos. But you really need to see the next one. So this is going to be 2 videos. That's how I have to download YouTube. That's how YouTube rolls. So I'm going to rationalize the denominator here. So I got to teach how to rationalize the denominator. You need to see this, and then I'm going to do a homework assignment. So this is a homework I'm going to do with another example. If you know how to rationalize the denominator, and you don't need to watch that. And if you think you can do the homework without me, you will not need to watch video part 2. So I'm just going to go ahead and stop here, and I'll do a video part 2. You don't need to watch it. Don't worry about watching it. Ciao.